Imagine a world so distant that sunlight takes over 5 hours just to reach the surface. From this far out, our sun is nothing more than a bright point of light in an otherwise dark sky. At this distance, the temperature drops to minus 230 degrees Celsius, so cold that water freezes into a substance harder than rock. Here, a single trip around the sun takes 248 Earth years. We only discovered this place in 1930. Clyde Tombaugh, a 23-year-old astronomer, found it by manually comparing thousands of star photographs, looking for one tiny speck that moved against the background of the galaxy. An 11-year-old girl, Venetia Burney, suggested the name, Pluto, after the Roman god of the underworld. It seemed an appropriate title for a world so far removed from the light of the sun. For the next 76 years, Pluto was celebrated across the globe. It was the cherished 9th planet, the final outpost of our solar system. That classification changed in 2006. Thousands of scientists gathered in Prague to create a formal scientific definition for what actually constitutes a planet. The new rules were specific. A planet must orbit the sun, and it must have enough mass for its own gravity to pull it into a round shape. Pluto met both of these criteria easily. However, a planet must also clear its neighborhood of other debris. Because Pluto shares its orbit with thousands of other icy objects in the Kuiper Belt, it failed this final rule and was reclassified as a dwarf planet. At the same time this debate was happening on Earth, the New Horizons spacecraft was already on its way, traveling at 58,000 kilometers per hour. While the world was busy labeling Pluto as a sterile, frozen relic, our first close-up mission was approaching a world that we had only ever seen as a few blurry pixels. In July 2015, after a 9-year journey, New Horizons arrived. It didn't stop to orbit. It shot past at 12,500 kilometers away, collecting as much data as possible during its brief window of proximity. The high-resolution images revealed a stunning feature that no one had predicted. Stretching across the surface was a massive, pristine, heart-shaped region of ice. This heart is actually a giant basin of nitrogen ice. It isn't a static sheet, it's a collection of glaciers that flow like slow-motion rivers across the landscape. These nitrogen glaciers flow between jagged mountains that rise 3 kilometers high. At these extreme temperatures, the water ice that forms these peaks is so hard that it acts like solid bedrock. The lack of craters in this region shows that the surface is young. Pluto is geologically active, constantly moving ice to erase the scars of old impacts. Pluto's tilted orbit is so stretched that it occasionally crosses Neptune's path. As it approaches the sun, surface ice warms into gas, creating a temporary nitrogen atmosphere. As Pluto retreats into the deep cold, this atmosphere collapses, freezing and snowing back onto the surface. This cycle creates tholins, organic compounds formed when ultraviolet light hits atmospheric methane. These tholins settle on the ground, staining the icy surface a deep reddish brown. A world with its own seasonal atmosphere and complex organic chemistry is a far more sophisticated system than the dwarf label originally suggested. Beyond the activity on the surface, scientists are now looking at what might be happening deep inside Pluto. There is evidence suggesting the presence of a liquid ocean hidden beneath the crust. This is possible because of radioactive decay. Heat from the rocky core could be warm enough to melt the bottom layer of Pluto's icy shell, keeping a vast reservoir of water in a liquid state. On Earth, life thrives around hydrothermal vents on the dark ocean floor, surviving on chemical energy rather than sunlight. If Pluto possesses internal heat and liquid water, then this freezing, distant world might actually hold the ingredients necessary for microbial life. Pluto demonstrates how easily a world can outgrow the definitions we try to assign to it. The data from New Horizons is still being analyzed today. Each new finding forces us to reconsider what we know about how small worlds function at the edge of our solar system. We now see Pluto as a place of flowing glaciers, water ice mountains, and a cycle of atmospheric snow that paints the surface red. The farthest reaches of our solar system are home to vibrant, complex environments, proving that even in the deepest freeze, the universe remains active and full of surprises.